So you are in a very cool session. Congratulations. You found the best session here at Ignite to go through stuff. My name is Angelo Comazzetto. I'm the Technical Director of Cloud here at Riverbed. We're going to take you on a pretty good journey in the next few minutes. We're going to show you some stuff live, which will work flawlessly, no doubt about it. And you're going to leave here with a really good understanding of some things you probably didn't know were possible up to this point. And if you've been reading about certain things like SD-WAN, cloud migration, a lot of people are going to throw a lot of slides at you. We're going to have little slides, and we're going to do a lot of action. So it should be kind of interesting, at least, to see things really working. I'll be joined on stage very shortly from someone from Microsoft. Her name is Reshmi, and she's one of the principal PMs from Azure Networking. She'll tell you a little bit about our partnership and what Azure Networking is and how big it's gotten. It's quite exciting. And then near the end of at the end of my piece, we'll actually show you some of the deeper visibility things that we can do. So we have a lot of good content to show you today. So a quick overview about Riverbed before I hand the stage over to Reshmi. A lot of people might have heard of Riverbed. We're a really large company. We have some 28,000 customers, including 98 of the Fortune 100. We're in almost every network out there. If you take a stroll through some data center, you usually see our boxes humming away merrily, making things go faster. We have a very broad suite of products, ranging from connectivity to our core competency and optimization, as well as some several new efforts that we've done lately around wireless and around user management and end monitoring, network performance. A lot of cool products in our portfolio. We are going to talk about one or two specifically about those today, some of the ones that are in the area you've come to this session for, about where you might not have thought that you might expose yourself to some new problems as you lift and shift or as you bring things up in the cloud. There are lots of connectivity things that we want to let you consider, and we want to show you the solutions for that. But before I give you an idea of what we're going to show today and delve right into it and take you on a bit of a cool tale with dragons and castles and things like that, I'd like to welcome to the stage Reshmi Yandapalli, who I always mess her last name up, but she messes mine up too, so it's OK. And she's going to talk a little bit about Microsoft's network and about what she does here at Azure.
Thank you, Andrew.
Yeah.
Are you able to hear me? All right.
Everybody's awake now.
So thanks, Angelo and the Riverbed team for bringing this together. This was very quick, and I was pretty surprised when they came up with this idea. And it was a very pleasant surprise because this is a fantastic forum to kind of share with you the information that we'd like to share at a broader scale about some of the nuances, and the Riverbed SD-WAN solution that I'm sure he's going to go over is going to clarify and clear out quite a few things that commonly affect the person on the floor, which is the person that we care about the most. So before we get started, I wanted to flash this slide, which is the slide that we have actually started to show a lot more about the scale where Azure is. We don't do necessarily a great job talking about it all the time, but now we've started to be not shy and talk about it. We are in 42 Azure regions with 8,000 plus ISPs and 100 plus edge sites. And if you were to tell us how big are you relative to, let's say, another public cloud provider, there is no competition. So it's everywhere, except for maybe some other planet. We are pretty much everywhere. So if you needed to get to anywhere on this earth, we are pretty much there. So that gives you an idea about the scale. And when we started to talk to customers about it, that's what became much more obvious. They said you're there everywhere. So there is some pipe or highway or some kind of a connectivity solution that's coming to you. But what are you going to do about your on-prem side? Are there branch solutions out there? Is there SD-WAN? And how do you see SD-WAN, which is something that I'm going to talk about? So always good to know what we did in the past. History is always a great idea. And I don't know how many of you went to the networking session, the Azure networking sessions. And if you did, there's a bunch of features that we have released. And so for someone who's a customer here, if you are thinking about a feature that you see in this list, feel free to check out. There's some wonderful improvements that we've done, especially that spans network virtual appliances, such as the Riverbed appliances. There's multiple NICs. Now we don't have any more primary NIC versus secondary NIC features. So if you're looking for that, that's something to explore. We also have multiple VNet enhancements, load balancer enhancements that we have done in the past. So there is a huge list, and we've just taken the top 20 items that we could fit in one slide. With that said, this Ignite, we introduced a bunch of features, and I am so eager to touch on the pitch for Riverbed that I'm going to scope it out to top 3 features that is definitely something to check out. One is global VNet peering, and what that is basically the possibility of peering across regions. And this is something cool and new, and this is definitely going to help you out. So if you're a customer that's checking out Azure or is already comfortable with Azure and you haven't heard about it, feel free to reach out to us. And if you are a Riverbed customer that's thinking about Azure in ways how you can do more, then this is something that you should also go and investigate. The second feature that we have actually introduced I would say a few months ago in private preview, and now we have opened it up, is something called the ILB-HA port. And what this does, it basically gives you the ability to have high availability across virtual appliances. So if you had a Riverbed appliance in a virtual network, you could basically put it in active-passive, active-active, any kind of mode behind internal load balancer. So a question that gets asked very frequently is, are you going to do it on the external load balancer? And this is something that's also we are looking at. And the third feature, not the least, is the biggest one, which is the VM to VM bandwidth that we can now process is about 30 gigs, and there is no competition. So if that hasn't internalized yet, I suggest you do that. Any questions here? All right, so all of you have gone to the Azure networking sessions, I'm assuming. That's great. Awesome. So now to the thunder, which is, that was not the thunder. There you go. Okay, so this is where I need to put in my Microsoft hat and share with you a story. So 2 years ago, we were talking to a customer, and the customer came to us and basically said that, hey, you know what, we have all these branch offices and we have multiple links in there. We have MPLS links, we have internet links, and we have multiple links that are going somewhere. I wish you guys could figure out a way in which this lift and shift story to cloud would make a lot more sense, also keeping in mind the on-premise side. So we started to talk a lot more to some of our other customers about SD-WAN, and for those who don't know what SD-WAN is, it's software-defined WAN. And for software-defined WAN, as to what was really, helping them out. And they were saying this branch management solution that's easy to deploy, that is very easy to configure, and you just don't need to think about those double clicks and the triple clicks of networking. So that's what got us thinking, and we started to explore this journey with Riverbed to look at a way in which it could be easy to assume that, yes, you want to connect to Azure, go ahead, go for it. So now, we've done quite a bit of technical work with them. There is a button on the Riverbed Steel Connect panel that basically gives you a highway into Azure. So, and that's something that, Anjali, you're going to be demoing today, right? Absolutely. You're going to talk about it? Awesome. So what I was wanting to talk about that specifically was the cost aspect, the simplicity aspect, and the single pane of glass. So when I am the IT or the network engineer on the floor, and I'm suddenly having to move to the public cloud because there's a lift and shift, all the benefits of public cloud, the first question that me as a person on the floor would be having is, I had all these controls. I could go pop out a wire in my branch, put it somewhere else. I had all this control. But now suddenly I'm having to move to the cloud. And then how do I control those branches? Is it possible that I have this magic box out there which can be zero-touch provisionable? You plug it in, it somehow magically knows it, and I can still control it centrally from somewhere? And that's what got us to Riverbed. When we looked at the Steel Connect solution, we were like, oh my goodness, this is something we need in the Azure marketplace. And voila, the team basically bent backwards. They put whatever it took to make this solution available. And that same customer, when they got a demo, they basically said, it's that simple? Really? Is there more to it? So the crux of it is, it basically gives you the comfort level to get to the public cloud. You get the cost aspect of it, because when you do the math of what you're saving with zero-touch provisioning systems in your branch offices and moving to the public cloud, which makes the lift and shift easier, it adds up. I mean, it's a huge cost savings. We've seen 4x to 15x. So that's the number out there. And so depending on the organization, you can do the math. The second most compelling reason that customers have told us that they are looking at SD-WAN solutions is the simplicity aspect. So simplicity, simplicity, simplicity. That's like the crux of it. Every time somebody says, hey, I want to do this knob and this policy and this route and this filter and this something and this, that something, that gets complicated, because when you're moving 500,000, 20,000 branches and you're trying to deploy it, it becomes a big challenge. So if you had some kind of a branch management solution where you could go in and say, you know what, I don't want this organization to have access to app 1 and 2, and I want that applied across all my 1,000 branches, it's just one rule. And that's fantastic, because that gives you choices, which is where the path selection aspects of SD-WAN solutions come in. So on that note, I want to leave you with this thought that if you are an Azure customer and you're exploring SD-WAN, please do, because it gives you huge savings in resources, in money, and in simplicity. And if you are not an Azure customer and you're exploring it, please feel free to explore the SD-WAN solutions, especially Riverbed, because the solution is just simple. Thank you.
Okay, so before we get started, the one thing that we always like to do is there's a special gift. So when you came in, you were given your lotto number. I said we should give away a car, but marketing didn't like that. So instead, we're going to give away a cool piece of technology after. So if you're thinking of leaving or you have to run, you must be here to win, of course. We'll try not to keep you for too long. But if you're planning to duck out and we haven't reached the end yet, then you'll forfeit your rights and we'll have to draw another number. So don't do that. So I'm going to take you on a little bit of a journey, and then we're going to get right into a demo. So I want to tell you a little bit about a tale that might relate to you. So this is what your network probably used to look like. If we go back far enough, you had some branches, you had a data center, things needed to connect. You did that with traditional networking. You went to school, lots of command line fun, add new branches, rinse and repeat. However, as you get out there, the WAN has gotten a lot more complex. You have more choices as an admin. You have places where you can put things. You're trying to move things between those places. You're trying to lift and shift. You're trying to add new services. And therein kind of lies the problem. You're evolving your network, and you have a lot more choice than you ever had in how that looks, what your cost is like, and where the network sits. So in a sense, the data center is something that has changed a lot. So in the past, this was kind of like you went to bed at night and you were like, everything is safe. It's in my fortress. I know the walls. I built them myself. I know the guards. I hired them myself. Everything is exactly what it should be like. But in reality, if you were to look at your data center closely, your organization as a whole on a day-to-day basis, it's probably more like this, right? At somewhere in some point, there's a fire to fight. Somebody left a port open on a firewall. Somebody downloaded something they shouldn't have. Somebody got their hard drive encrypted, and now people need bitcoins from IT to pay for it. There's all sorts of reasons why your fortress is coming under attack. And that's, to me, as a person who's very passionate about cloud stuff, that's, to me, the key underlying principle that the cloud has offered that you couldn't do if you go back just a few years. And that's the promise, which is this. The idea that if you give money, and usually not a lot, depending on how your scale is, if you give money to Azure, they can make a whole bunch of things not your problem. You can put things in the cloud, and there's a lot of things that come off your list that can catch on fire. You don't have to go walking through racks of servers and look for a failed fan. Somebody didn't leave a power cord half plugged in. Which cable goes where? Whose box is this? You know the cloud story by this time. But that's the premise. And the question is, how do you get there? What is the way that you as an organization end up in the cloud? And it might be something like this. You might be sitting there one day. It's one of those days where you don't have a lot of things to do because things aren't actually on fire. You don't have 20,000 emails that you have to get back. You don't have 20 new branches in 5 countries you have to deploy tomorrow. And so you start looking at what it is to do this cloud thing. And you went to the very first time you logged into Azure. What did it look like? It probably looked something like this. You logged in, you made an Azure account, because everyone here has one. And did you actually start by doing full user-based planning? Planning all of your VNets, planning all of your regions and all of your subnetting and all of the services, activating two-factor authentication? I'm betting you didn't. I'm betting instead you did what I did, and you fired up your first server. And then you went, wow, that's a neat server. Let me just make one with like 100 gigs of RAM and a half a petabyte of storage or something fun. And then it starts to set in that you had almost unlimited chops when it comes to serving and compute. You were like, this is going to be great. I can have 400 servers. I'll just write a script. And what you did is you started spinning up servers and finding a use for those servers, and then started applying those to problems you have in your organization. And you were so happy with yourself, you made what's probably your first biggest mistake. You went and you showed one of your friends at your company. You're like, John, look at this. I made a server, and I made 20 of them, and it's all doing it automatically, and I can feed this app, and it doesn't matter if we grow by 1,000 clicks in 1 second, we can still serve that. And instead of being impressed, what did John do? I want that too. So you were like, no problem, I'll take all my cool knowledge I've spent over the last couple weeks, and I'll make you a template. Because then John went and told 2 people, and they told people, and suddenly you have all these different departments throughout your organization also wanting unlimited computing capacity at a moment's notice so they can do their things. And they don't have to order servers. They don't have to put in POs. It's all rev rec on a credit card. So you just con someone in the company out of their credit card, and you can start racking up a bill. And you ask for forgiveness later. And that worked out OK. And then what happened is they went and told more people, and more people, and more people. And every day you went home, you came into work, and suddenly you woke up one day, and you had a whole new global network. But in this time, it wasn't in your data center. It was spread out amongst 10 data centers in 15 countries, and you have regions, and you have all these things going over the place. And you're like, how did I end up at the network admin of this whole cloud network? That's not OK. So your attitude might have changed. You woke up the next day, and suddenly the users at your company aren't your friends anymore because they're causing you more work than you had before, and the fires are a different type of fire. It's a scale fire. It's a work fire. The stuff that's in the cloud is working great, but now it just exploded in popularity, and so this is your problem. And so as any good party, if you throw a good enough one, the hobbits show up. And they want to drink and they want to eat for free. So the very first thing is, how do you get to these resources you're firing up in the cloud? This is the key problem. Microsoft refers to this as the last mile. How do you get to these resources? There's lots of choices, lots. At the beginning, you probably just did a port forward through. Maybe you did that. Maybe you fired up a personal VPN from your laptop and set up the Azure VPN service, and you got in. But then you started to say, well, I'm going to build these apps in the cloud, and we've got lots of data. We have data centers. They're big. And so you probably ordered a Microsoft Express route. And those are great. Those solutions are very high bandwidth. They're very calculated. And they allow you to empty the contents of a data center at speed and at scale into Azure. However, when you have something like that, you're able to use that connection. But more importantly, as you have more and more branches in more locations, they also want to get into Azure. And you can't put ExpressRoute at an individual branch, because ExpressRoute needs you to get to an ExpressRoute data center somewhere. And usually, if you're an admin, the first thing on your list when migrating to the cloud isn't to design a solution where you can retool your entire network to provide a direct path from every branch. That's the most ideal solution, but it's also the most tedious. And then the users come along in droves, and you have hundreds of branches, and all of those applications you're putting into Azure, they need to be there, and they need to have a measurable performance increase as well. They can't be slower than before. The cloud is nice and fast, but where the users before were going right to your data center where the applications were, now they're routing to the data center, and then to the ExpressRoute entry point, and then in. So it wasn't designed as a branch connectivity solution. And as a result of that, you're not doing the heavy lifting with the servers that you were doing before, but you're doing a lot of manual tuning. It's not complicated work. I don't like that word. Complicated means I need to sit down, I need to flex my muscles and figure out how to wrap my head around this. It's more just tedious. You as an admin know what you need to get done. It's just a lot of work, and it shouldn't inhibit your scale of cloud adoption. You should be able to fire up new branches at a rate of 2 or 10 or 100 per day if you have everything set in motion correctly. However, connecting those branches into those valuable resources where you're offloading your compute and offloading your responsibilities on the hardware should be the easiest part of it. And that's where things can go a little bit downhill. And so what it ends up is, you're trying to sit in your office and drink coffee because you've adopted the cloud, but really you're sitting there retooling a manual router or a manual branch device you bought 5 years ago that you never bothered replacing because it doesn't really do much. It's just a simple router getting people to the data center where they then go out to the internet. That's where my filters are. That's where I keep my big web products, things like that. And so the promise that you were looking for is delivered in that area, but it created you a new volume of work. And the problem with that is that volume of work can explode very quickly past the point that you were trying to solve by moving to the cloud. And so what you want is this. You want to be able to connect your organization into those cloud resources in the best possible way, but more importantly, in the most efficient way. So you want something like this. You connect a branch, but then a different branch has different VNets. They fire up more VNets, different applications, marketing, security, anything that you can think of that's an internal app, the workforce. And every single branch may have different requirements for which VNets they need to get to. And you can't plan for it because tomorrow you could have 10 more VNets for a certain application for only certain branches. And so the problem becomes a cascading one. And even if you manage to script yourself a solution or tool one out by hand, you end up with something like this, and it only gets worse. So in a perfect world, how does that look? You actually want something like this. You want to reduce work by having limited breakout points. But sometimes then you need to do transit routing. You need to have everything coming to a central point, which is a central point of failure, where you need to keep gear. And I had an administrator once tell me, he's like, I'm trying to get rid of my data center. I'm trying to put it all in the cloud. So I had this vision in my head of this big data center. It's super dark, and it's dusty. It hasn't been used in a while. And over in the corner, there's one server with one light, and you can just hear the fan humming away, and that's the transit routing point for all of the branches, which are VPN'd there. Because normally, the VPNs don't get touched a lot. It was like, well, Bill set that up 10 years ago. That's how my branches get to the data center. And it was just easier to transit route those over to Azure than retool individual boxes in the branch. Most of them I've never actually visited in my career. So it turns out there's the right approach. It was just on the wrong side in our tale. In Lord of the Rings, there was the Eye of Sauron. And it was this great intelligence that it saw everything in its kingdom. It knew where its armies were. It knew where it was in control. It knew where it needed to work. Somehow it didn't know that the most important thing that could kill it was right under its nose, but that's a different problem for the writer. I didn't make the story. But the concept is sound. If you can see everything that's happening in your network using technology that you've deployed, that isn't a lot of work, and that's able to execute on your orders, then all you really need is orcs. You don't need smart generals to think on the ground. You need to devise a plan and trust that those orders will be followed implicitly. You don't need them to develop new styles of fighting. You need them to do what you say. And if they can execute that with great efficiency, you can get rid of generals and all of the middlemen in between and get right to the source of the problem. So the solution is software-defined wide area networking. And the key part is SD, software-defined. We're not trying to sell you a new technology of networking, a new protocol, a new encryption standard. People want what they know. They want tunnels. They want encryption they can trust that's been certified and things like that. They just don't want to do local subnet, remote subnet, encryption key. If you've done any kind of VPN work in your life, you've spent a half an hour debugging the fact that you messed up a lifetime or a protocol in the security policy, and that's why that VPN tunnel to that stupid box that's 3 years old never came up. We can remove all that from the table for you. And in doing that, we're going to show you not only how you can connect your company together, but most importantly, how you can connect everything into Azure. Now, before I show you the demo, I want to tell you what Steel Connect is. Steel Connect is Riverbed's SD-WAN solution. That's our name for it. It's basically a complete line of products. So for that, we have Steel Connect Manager, which is your central throne room. I'm going to show you all of that in just a minute. And you can choose between several different gateway models we have. We also have switches, and we have very good access points with our new colleagues from Xeris as well. Now, one of the most important parts to remember about this is it's not just another box. Boxes are easy. I can point 5 colors, 5 different companies that will all try to sell you their box. Here's the difference. Most boxes were built from the ground up to be managed from the console on the box. Later, the companies built a manager of managers, the multi-manager, the thing that could distribute policy in mass and distribute configuration in mass. But those boxes were never built from the ground up to do that. So with Steel Connect, you don't log into the boxes first. You don't pre-provision them, set up the WAN interface, put a license key in them. None of that. It all goes out the table. It all goes off the table. The box itself is an orc. You plug it in. It comes online. The Eye of Sauron sees it, and it does what it's told instantly without you having to do anything about it. That core concept of visibility and how we see the network enables me to show you the automation of networking that I'm going to do here today live without any pre-canned stuff. So that's the product. Let's have a look at what it can do. First is it's a great SD-WAN product. It allows you to use a mix of links at all of your branches. You can have MPLS, you can have internet, you can have branches that have none of one and all of the other. You can offload, you can do very intelligent steering. It's normally beyond the course of scope that we use in a cloud demo like this. I'm going to focus on the cloud piece, but it is a full-featured and one of the best SD-WAN solution you can buy today, right now. It also has great cloud connectivity. That's the piece I'm going to demo. And then the branch networking itself, how you actually connect branches to the whole company and are able to apply security and policy. I always, when I talk and demo Steel Connect, I say think of it as 2 layers. We have a routing layer, which connects everything together and provides pathways that traffic can take. And then we have a permissions layer, which can steer the traffic in a certain manner, break things out directly to the internet, and control what's allowed to flow over those green lines that we show you between sites. So I'm going to demo all that in just a minute. So I'm going to switch to a browser where I have a waiting demo, and we're going to have a look and see what it, and actually show what it looks like here. Apparently that just jumped ahead 10 slides just by clicking something like that, which is awesome. I guess if you push the down arrow, it does that. So let's minimize that and open this. And I'll just switch that over there. I actually just want if the monitors could just show or replicate all that. You can just put it on that monitor and I can do it like that. It doesn't have to be cloned or mirrored. Yeah, perfect, that'll work. Okay, so what I've got here is I've set up a company. It's called the Global Research Group. And this company's already deployed some of our Steel Connect boxes. So they have a few sites spread out across the world. They have a site that's still under construction, which I'll get to here in a little bit. And the point is that you see a bunch of green dots on the map. And those boxes, they just indicate that there's something online there. Now, the basis of SD-WAN is link management. That's where we start. Without the connectivity between sites using the available links, most of the benefits aren't possible. So when I click on a certain site, the first thing you see is that it's connected to 20 other sites. And every site, in fact, is connected to every other site in a fully automatic mesh. Like many of the things I'm going to talk about today, this is not something that you cannot live without. You don't have to do it this way. You can say certain sites should do hub and spoke. We should say certain sites go to this data center, certain sites go to the other data center. You don't need to do it by the default ways. Just the organization here that I'm using, they want to connect everything together in a global mesh. Now, this company wants to connect to Azure. And so before I do that and kick off that automation, I want to show you just a little bit about what you're looking at. With our product, because we're not actually logging into an appliance and saying Ethernet 1 is the WAN, and Ethernet 2 is the DSL link, and Ethernet 3 is the LAN, we don't have to do that. All we have to do is go to our network design, and you can see our sites. And sites are just physical places where people go to work. So I've got some sites on the map here. Sites have 2 main components for this demo that I want to focus on. The first one is uplinks. So an online site, wherever it is, we can actually pick one here. We can see that currently Auckland, it has an internet connection. And that internet connection is obviously plugged into a box, but I don't have to go to the box. SD-WAN is not about the actual appliance. It's about the branch. It's about the site. And the nice thing about that is you can set up an internet connection before you even assign it to a box. And the system can do all of that ahead of time for you. We also have this concept of zones, which you might be familiar with as subnets. So if I look at something like Auckland, we can see that Auckland has 2 particular zones. It has one for its clients and one for the VoIP. And they're assigned VLANs. It does all that automatically for you. If you use Steel Connect, if you don't want to, you never have to type another VLAN number for a new branch. We can just assign them for you. Now what we want to do is we want to connect our 20-site company to Azure into a VNet where I'm building a new app that I want to expose to the company. Normally, I would struggle with this. It wouldn't be something I can do in 5 to 10 minutes with almost no networking knowledge. And I want to show you how it looks like, not only when you add a new site, but when you connect something to the cloud with Steel Connect. So if I go down here and I click on the Azure button, I've already added my account into Azure, my Azure account into Steel Connect. We will allow the Steel Connect manager to interface with my Azure account. And we do that with a set of credentials. We add that in. And if everything's OK, we show you that, yes, indeed, we're good to go. Once you've added Steel Connect Manager and given it the right permissions into Azure, we can look at a list of every single VNet we have in every location. My name being Angelo, I named my VNets Angelo. So there's my VNets in Azure. I don't need to log into Azure. I need to make the VNets first. We don't do that. And what we're going to do is I want to publish one of these VNets as if it were a site. Because why do I treat it any differently? It is a site. It's just in the cloud. So let's connect my iOS subnet. Just takes a second. And by clicking that, nothing changes in Azure yet. All I've done is set up a brand new site I didn't have 5 seconds ago. And that site itself is going to show up here. And we can see there's now a site called Azure. Now we have a place where people go to work, or in this case, where apps go to work. And more importantly, with a physical site, I'd need to type in a few subnets. But because we can read all of that from the Azure API, if I come down here into zones and pick the site, there it is. It's added, it knows the IP address, we're ready to go. We also have an uplink. The uplink isn't online yet, but we know that we need to talk to it, and we use an internet connection on this demo. So let's look at that site. And we can say there's an uplink. So we know that there will be an uplink there. We know it will be on that appliance. The appliance isn't there yet. So if I come down here to appliances, you can see it's offline. It's pending. We don't actually have an appliance deployed in Azure just yet, but we're going to deploy one right now. And while that's deploying, I'll then talk you through what we're doing. So when I come down here, let me go to deploy. And by deploying, I'm actually going to kick off something in my Azure account. So I'm going to pick one of our instances. These aren't bandwidth limits. These are kind of like the worst case numbers. We don't limit anything there. We're always limited by the networking performance of those instances. So some people, depending on the traffic and the network conditions, you'll get way more performance than we list here. We would rather underpromise and overdeliver than do something differently. So I do that, and I'm just going to leave the automatic routing on right now, and I'm going to deploy this. Now, the first thing is, as this is deploying, it's going to look through that subnet in the VNet, and it's going to find a couple of subnets that are free. If it can't, at any step in this demo, and at any step in any operation, if we can't do what we want to do, we fail out and exit gracefully. We also don't touch anything that's existing in your deployment. There's nothing I hate worse than when you trust a vendor to do something and you give them some credentials and they carpet bomb your very carefully placed networks and things like that. They start changing things. You know what I'm talking about? Because then you went, you know what, I don't like these guys, and you go undeploy, and there's fragments and shrapnel and stuff all through your organization that you have to delete and remove, old security groups and stuff like that. We don't do that. If you don't like us, which is very unlikely, but it happens, or you don't find a use for us in the way that we say, you can click a button and we are gone. We're not even there at all. You won't even know we were there in the first place. We do that because we actually build a couple of subnets just for us. We deploy our gateway in the middle, and we basically build a door. Once this appliance is finished deploying and it's booted up, the very first thing it's going to do is what all security products should do. It's going to update itself to the latest version. So you're not 6 versions behind, missing some patches and some critical vulnerabilities. So in the log down below, as this appliance kicks off, we're going to see it come online. And it's going to take a few minutes because it's going to have to boot the instance. It's going to realize the instance is at a version that's not quite current, and it's going to update itself. And while it's doing that, something else is going to happen. The appliance, when it's fully booted and has rebooted once at the latest version, is going to automatically build a VPN tunnel to all of my other Steel Connect appliances. We do that because we know the current external IPs, we know the internal IPs that are needed, we know the security policy that we're going to use, and so we're going to start to see green lines spider out from this appliance. Now, the appliance itself is a dogleg. It's sitting in your VNet, but it's not sitting in path. We're not touching your individual machines. You don't have to go there and change their default gateways. I mean, we can't replace the default router in Azure, but what we can do is provide you a routable target. So what we do is when the appliance is fully online, if you use the automatic routing option that I just said yes to, the only running change we're going to make to your infrastructure is we are going to change the route tables by adding UDRs, user-defined routes, to say if you need to see these traffic, these networks at these remote sites, send that traffic to our gateway instead. So all of your other routes you have in place are still going to work. However, now a network that needed to see the branch or the branch that needed to see the network will be able to do that automatically. If you turn that off, we allow you to do that. If you don't want us to touch your route tables, if you're a routing guru and you're like, I've carefully put every single route in my company in my route table, don't touch my routes, that's not a problem at all. If you go to the site for Azure that you're interested in, we have a table here called Azure Routing, and we will tell you, based on your company configuration, which networks you should be sending to which interface in Azure once the deployment is finished. It will actually tell you what the route target should be. In this case, you should route the networks below to this particular IP address, which is the IP of our gateway that's being spun up in Azure, so that we can attract the traffic. And from there, we dump it into our router and our VPN tunnels and go from there. So you have your choice. You can let us handle the routing for you, or you can do the routing yourself. We have APIs for this. You can update the APIs and do all the cool stuff you like. Now, more importantly is optimization. Not only can we connect those sites together and make the lines between them, but if you are a customer of our Steelhead appliances, which are great at accelerating the heck out of many types of traffic, we can allow a Steelhead to be placed behind this shiny new gateway I've put in Microsoft Azure. And we can do that really simply by just going down here to the Azure piece, clicking on deploy instances. We can manage it and do it at deployment, and we can just go like this, and that will then tell us to place a Steelhead behind that as well. So if you're not yet a Steelhead customer, I'd encourage you to check out that technology. It's fantastic stuff. But if you are, and you'd want to use your steelheads to accelerate things to the cloud, the same way you're accelerating things to your data center, we can do that for you natively. And all of this will now happen while I'm on stage with you, not entering network things, not matching up parameters, not putting Post-it notes on 2 different pieces of paper and drawing lines between them so I get the parameters all right. That's all going to happen here in real time. And now, if we go down to appliances, we can see that we actually have an Azure appliance. It's online. It's got things ready to go. We can see the IP addresses it has. If I was to log into the Azure console, we would see it running. It's a physical machine in this particular VNet that I can apply my own monitoring and reporting to if I like as well. And more importantly, when the steelhead is ready to go, it's not yet online. When the steelhead does come online, the only difference is that we will route the traffic first to the steelhead, and the steelhead will be automatically configured to send everything to our gateway. So you don't have to log into the steelhead either. It's literally a full end-to-end network automation doing the things that you as an admin know how to do. We just don't make you do it. That would be silly. We know what you want to do. You've told us. We'll do it for you. So now if I come down here to network design, or sorry, let's go back to the dashboard here. We can see that this site is starting to come online. Tunnels are going to start to be built. We need a few seconds, a few minutes sometimes of data before we declare everything is OK, because we monitor things in very real time between the links. So these will start coming green in just a minute, and they'll start turning to green as the map refreshes. While it's doing that, I wanted to mention one very important thing about SD-WAN. Not only can you connect everything together, but from there the real magic starts. Then you can start to see exactly what's going on and what those tunnels look like. So if I grab one here, let's see which one that has some actual data going across it here. Just give it a second. Maybe this one. I want this one between Azure and my different thing, but we need that to come online. We'll show you that it has certain latency, certain packet loss, and all of that happens on an almost per second basis. And that forms some of the base intelligence about how we can do steering for you. So while that's finishing, the deployment, it takes probably between 5 and 15 minutes depending on where you're deploying and how many tunnels it has to build, but it's still zero touch. I'm going to tell you what you can do once those links are up. And one of the coolest parts about it is not only firewall rules, which we've all seen, but traffic rules. And the traffic rules here are also software defined. You don't have to manually configure every parameter at every site because every site is different. It might be the same. They have internet, they have MPLS, they have DSL, they have cable, but they are different. And normally when you make rules, you have to pick those different parameters on a per rule basis. What I've done here, though, is I've made a rule that basically says this traffic, voice over IP traffic, should prefer to take the MPLS connection. So in this case, if my office on the ground in that region has 2 possible paths to exchange data between 2 points, if it has an MPLS and an internet, we call the internet-based VPN route VPN. That's just clever marketing speak. It should just say IPsec or something, but it doesn't. So in this case, with one rule, I've said at all sites, all the ones that exist today and all the ones that might come online tomorrow with the same zero-touch provisioning, please treat this type of telephony traffic as a preference for MPLS. I'm going to turn off the metrics, though, because that then doesn't do what I say. So it'll go to MPLS first and then go to route VPN. A more common rule, which you might have a problem, is how do I take traffic that doesn't benefit from central scanning? Something like Dropbox. Dropbox is a great web-based app. If you're like most admins, very few admins I know just let traffic go out from every branch directly to the internet. We'd like to, but there's too much liability. There's too much monitoring problems. So either you have an individual device at every single branch that you're maintaining on a piece-by-piece basis, in which case I feel sorry for you. If you have a lot of branches, that's a lot of work and a lot of licenses and a lot of patching. Or you're taking the more easier approach and you're backhauling everything to a central point where you're putting a big firewall, a big web filter, and you're controlling everything with just a lack of surface area, which is normally a better way to go if you're worried about multiple attack vectors and things like that. So what we do is let's make a rule and let's say, well, I don't really, as an admin, I don't benefit from having Dropbox synchronize across these links. Bandwidth between sites is precious. Readily available junk bandwidth out to the internet, that's easy. So it is possible with many products to start doing application steering. However, at this 20-something site company, if I just say all sites, if I pick a certain application, let me grab something like Dropbox here. Riverbed has some of the best application identification in the world. And I'm going to say, I don't want that to go over the link. I want that to go directly out to the internet. So with one solid rule, let's drop it down a bit because I really don't care about quality of service for Dropbox. People don't complain that it's really like insensitive and not snappy. So I don't care if it uses up bandwidth, but not at the expense of other things I might be doing. When I hit that one rule, submit, and turn it on, now Steel Connect is going to figure out what it needs to do to translate that rule into an actionable thing at every single branch office box I have. So in the entire company, Steel Connect will now reach out, and it will say, when you see Dropbox, no matter which link you have, as long as you have an internet-enabled link at that branch, it will dump it directly out. Now, in this situation, if you only had an MPLS connection, that would cause Dropbox not to work correctly. So in this case, I actually want to go back and edit that rule. And I want to actually say that, oh, also, I don't mind if the internet is down or there's a site that doesn't have internet. Let's also add MPLS to that so that Dropbox isn't something I'm only restricting to internet connections. And again, by clicking that, that rule goes out and takes effect. And I can do this for any combination of things you can think of. I can give priority traffic to a distant destination. I prefer to do it by app, but I can do it by a certain thing like a VNet. I can say at every location, please use the internet connection for talking to the VNet. If I also has an MPLS connection there, only use it as a backup. And more importantly, I can actually say, if for whatever reason I don't want to pick one over the other, you can derive a lack of bandwidth across most communication links by latency. No matter how much bandwidth you have, one of the biggest challenges with admins that they tell us, they're like, well, I have a 1.5 megabit MPLS circuit, and I have a 50 megabit DSL. However, they have different quality of service, they have different guaranteed bandwidths and things like that. So my preference is I would like not traffic to use one over the other, but use the best possible link at any given time. Well, what's best? If you've ever configured quality of service and you've had to type in your minimum and maximum bandwidth, and you've missed a 0, and you've given your site 1 megabit instead of 10, and you couldn't figure out why everything is slow, because a lot of those ones, they need a base amount of bandwidth to know how to do their slicing. If you take a more latency-sensitive approach, you can figure out that as any link gets saturated, latency goes up. And so what we can do with latency-sensitive metrics is with one checkbox, we can make it and so that the steering decision over which link to take is done based on the link latency quality. So if one link is at 100 milliseconds and one's at 25, we'll add a few to that second link, and as the latency then comes up, we'll bring them up in sequence and bring them down in harmony as well. And you can do all of that with one rule across your entire organization, and that's a real big time saver. Instead of making you pull and move 50 different switches to get that perfectly, you basically have a button now that says, handle it for me, and use my links in the best possible way at the branches which have multiple links. If they don't, this rule doesn't get involved. So the type of things that you can do with SD-WAN are very broad, or you can be very granular. I can say for a certain user, I can say John should have YouTube access over the MPLS at all times at the highest priority. And the question is, if John shows up in some office he's never been in before, if he shows up in Singapore and he's never been there, the system will go, hey, John is on the LAN in Singapore. I have a rule for John, not a rule for Singapore or a rule for a certain subnet. So I'm going to make sure that the firewall opens up. I'm going to make sure the rule gets applied. The whole system is a breathing, living ecosystem. And that's the power of software-defined networking. You don't have to think of it as old ways, A to B, allowed, disallowed. If C shows up, it doesn't go anywhere, or I have to answer a phone call in the middle of the night. The CEO's in our office, and he can't surf. Why is that? All of those problems can be solved by you planning ahead using some very powerful rules. That's possible. Now, with Steel Connect, I've talked for a little bit here. Let me refresh our browser, because anytime you use a nice new version that's not released to the public yet, they managed to kill the refresh on the map for me. So if I refresh this, I'm hoping things will be OK. Not yet still. Of course, in a live demo, nothing works perfectly. Our appliance is online. I think we're still waiting for the Steelhead to finish provisioning. So it actually looks like everything is online. It's just a map issue. And sometimes the metrics need a few more minutes for the map. It's only been up for 8 minutes in total. So we should have map metrics in a few more minutes. I might not have been talking long enough. And we'll then be able to see that link quality before them. So Steel Connect is still a little bit complaining. Of course, I did the best thing that you can do in a demo when you're a presenter is make sure that you install the latest version just a few hours before you go on stage. But the idea there is that I can deploy it. It looks like the map is still updating. So I'm pretty sure that we will have green lines here in just a minute. And we'll be able to show you in real time how that works. So if it's not, you'll have to just trust us that that's how it works. The nice thing about this company that I've built is that I don't have to be a full networking admin. I do not need to log into the appliances, type command line parameters. I don't need to set up things in a way that I never had to. And most importantly, if I have VNets in every region, and I have a new admin coming at me or somebody in a certain region saying, hey, that application that you guys are running in Ohio, not a big fan. It's slow. I'd like to spin it up in Singapore. And you're like, well, we can't because the branches don't have connectivity there. So we'd have to get you here and then backhaul you that way. That argument goes out the window. I can spin up a whole new VNet in a whole new place just by going back to Azure. And let's look for a different one here. And we'll connect something here in Europe. And I can do a deployment there. And in the same 5 or 10 minutes, we'll spin up a different instance. And that will then provide me connectivity in that space. I'll put that one to manual routing. That's going to kick off a deployment there as well, and that's going to stand that one up. And now not only what's going to happen is that new VNet going to talk to every other subnet in my company, but it's also going to talk VNet to VNet as well. So the VNets themselves will have a path between each other. Now, Azure has lots of networking tools, and the rate at which they're expanding the options that you, the customer, have is actually really, really cool. They're adding stuff so fast that most people can't even keep up with the features quick enough. But in the same manner, if you are working with your network anyways, and you can extend all of that from one pane of glass, and then control traffic rules and make filtering rules and such on top of that, with all of the visibility that goes with it, that's a very powerful feature. So as we're spinning that up, first of all, the last thing I wanted to mention before I turn it over to some visibility talks are everything that we do in the Azure part is all done with their API. So everything is logged, both on our side and in their side. So any tools that you're running, everything monitors the API commands. You can do whatever you want to catalog that and run reports on it. Lastly, because this is something that's being done not natively in our application, you're deploying it from there, but you can log in and see it. You can see the VNets, you can see the things that we do, you can audit it yourself, you can make changes to it, and you can remove it. If you do need to remove it, click one button, and away it goes. The appliance we treat just like a real appliance. And so you'll see that that appliance itself does show up. It has a heartbeat. It has an uptime. It's very, very lean and mean. It can push a lot of bandwidth for you. And it provides you an opportunity to react quickly while you're waiting for more permanent circuits to provision, or you're trying to move off those permanent circuits if you're running something like a retail environment and you have to be quick, easy, it has to work, and you need to undeploy it 3 days later and move that to a different site. You can take those boxes with you and use them there as well. Now, having all of these links and having all of this intelligence between the links and being able to steer things across them is more on the networking side. And we can do a lot of very powerful things in that space. The one thing that you need to think about, though, is what's happening over those links. When those links are operational, what's going through them? How are those applications running? What are the best ways that I can deal with the things that are happening over those links? And more importantly, when the phone rings and someone says, hey, that app you've deployed, really slow. They're like, well, it can't be slow. It's in the cloud. The cloud's fast. And they're like, well, I don't know what's happened, but it's slow. Before, when I was talking to the old system, it was fine. But now things aren't running the way I want. Often, your visibility choices are going to be limited. However, with Riverbed, we can delve right inside that with a magnifying glass, and we can show you exactly what's going on. And for that, I'm going to bring on stage John Hodgson from our Advanced Technology Group in the Office of the CTO. He's one of our visibility wizards, and he's going to actually show you what it looks like to have that kind of visibility that you might not have seen ever before. I'm sorry I jumped ahead in your presentation. You have to find your slides again,
Perfect.
Sorry.
Oh, he's making me find my slides again.
I know, I wasn't. I just actually skipped like 10 forward by accident.
All right. Sorry, folks. Here we go. And then that'll give you time to get your links up, hopefully by the time we come back. OK, thank you. So we're going to switch gears a little bit. Angelo showed you all the wonderful things we can do to actually connect physical things together, or at least the virtual locations, hybrid from Azure to your on-prem. But there's other challenges that come when it comes to visibility. So visibility, to me, since I'm in the application performance space, is really about monitoring the quality of the applications and services that are running over this infrastructure. Right? Because at the end of the day, we're building all of these networks and applications so that people and devices that need our data can get to it in a timely manner. That's what this is all about. So there's a lot of challenges that come up in the new world when it comes to this complexity. As you talked about, user A told user B, told user C about this wonderful thing called Azure, and they started spinning up VMs all over the place. Well, now that also creates a visibility challenge that if we're trying to monitor quality of service and SLAs for different applications, how do we do that? So in the old days, we had a VM that we would run multiple apps on. And so the different colors indicate some different apps, and then the little subcolors, maybe some subservice. And this would be a thing you might have to monitor as far as, is this device up? Are these services up? And then maybe it would be a node in a map of dependencies. But then we started getting more complex and saying, let's split the apps apart into single app containers. And now all of a sudden we got a little bit more complicated. Instead of one thing, we had 6 we had to look at. And then we said, well, you know what? Microservices, that's the new way to go. And let's have microservices in individual containers. So now what was one thing I had to monitor, all of a sudden is 24 things, right? So this becomes much harder for me as someone trying to know when something's slow, where do I look? I've got a lot more things to look at. And now I have to track the interrelationships of these subservices, because the whole point of things like microservices is that we're all cross-sharing. So where all of this code used to maybe live in one JVM or one CLR, now they're actually traversing networks. They might be in different parts of the globe, right? Some might have stayed behind in our data center, and some we may have moved to the cloud. So this becomes very difficult to keep track of. So the complexity, again, is very, very tough. And then lastly, or next, is that the cloud affords us the ability to scale as we need to. So if we're trying to say, okay, these are the key services, and now we have, it's Thanksgiving, it's Black Friday, and I need to scale up some instances of a particular thing, I have a lot more things to keep track of. And then I don't need them anymore. It's now the day after Black Friday, I get rid of them. But they don't just go away, right? They existed, and they leave a trail behind that I have to keep track of. Because if I'm going to try to troubleshoot why something was slow yesterday, I have to factor in the fact that those virtual instances did exist, and maybe one of those had to do with why there was an issue, or a connection through one of those became an issue. So that becomes more complex. And then as we scale up again, maybe we're using more instances, we have to think about the problem of transience. So transience is that I may not be scaling up the VMs that I'm using, the quantity of them, but I may be moving them around with the position of the sun so that I'm closer to my users, or bringing them, moving them as I deploy new versions. So they leave a trail behind of dead orcs, if you will, that I have to keep track of because, again, I may have to factor those in. So now we think about that the complexity of that map that I showed a moment ago. There's actually even worse, because when I factor in now all of these ephemeral nodes that are gone, all of a sudden my world has become very, very complicated. So if I'm trying to keep track of what does my world look like, it's not a Visio diagram that I can just print on even a plotter page and put on my wall, because you end up with something like this. This is a real-world customer that are visibility products. We're monitoring the networks, we're monitoring the servers, we're monitoring the application code, the .NET and Java code, down to the class and method level, seeing what calls what and mapping it all out. And it's quite impressive that we're capable with our visibility of connecting all these dots, but who the heck can read that? That's become useless, right? And it's only getting worse. So we had to look and say, there's different approaches we have to take when it comes to visibility now, and we have to start abstracting things and not thinking in the old physical world. So we've come up with ways of taking that complicated map and turning into something we see here on the right, which is what we call a performance graph. And I'm using this as an example of different styles of visibility options that you have. But what this is a complete abstraction of the resources running inside this application, where on the left, they are the business transactions, and on the right-hand column, those are the root causes of delay. So we're able to map what things on the left are slowest and what things on the right are making them slow. So what that allows our customers to do and say, I have this ever-changing, super complicated environment where some stuff is on-prem, some stuff's in Azure, things are scaling up, scaling down, and I see this big response time spike. The performance graph at the bottom is saying specifically that the recovery service is the thing that is the slowest and taking up the most time of all the things my users are doing, and that maps directly to a particular piece of code on the right that I can go to my developers and say, hey, recovery service just went haywire, and it was that piece of code. Can you go drill down into it and do your developer-type stuff, go into call trees and so on? And we could say, well, that was a 5-minute period of time. What if we look at the previous 5 minutes, and all of a sudden we see that same recovery service was just a drop in the ocean 5 minutes before, and its time was because of a SQL statement. So we're able to very clearly show how things are behaving, and if there's some sort of delay, why. This is an example of the problems we're trying to tackle in this modern world. So to that end, perspective is a really important part, because, and you know what, just show of hands, who considers themselves more of a networking person than a server or code person? Show of, right? And then show of hands, who is a developer or a system administrator? Okay. And who doesn't know what they want to be when they grow up? That's the rest of you. Okay. So perspective, if we look at this, we've got a person stranded on a desert island, super excited to finally see a boat. They are saved. And if you flip that perspective, there's a guy who's been adrift for God knows how long, and he's so excited that he sees land. So depending on which side you're looking at, this is a very different story. And how this maps to visibility is that the different people in this room are going to think of this in a different way. The network perspective tends to be very physical. It's about where do things live, data centers, branches. How do they connect from one to the other? Okay, I've got my MPLS links, I've got internet links, and then I've got my links to Azure, my express route, and so on. And this is very much about physical things connecting to physical things. And there's nothing wrong with this perspective, it's very valid. But the application people are probably going to think of things more logically in terms of, I have a load balancer that connects to these front-end tiers of servers, and those make some calls to an authentication service with a database. And then here's account services connects to some file services, and so on. Again, just a different way of looking at things. So these are two different ways. And then the third, I'm sorry. So what I was going to say, the third important view, new laptop, new version of PowerPoint. Let me just get this video up. So he had his challenges, I have mine. He couldn't get his demo up. Hold on. Okay. So that's the third perspective, end user experience, right? So hopefully some of you got a little ticked off at me that I was wasting your time there. This is what matters. Delay. The stuff that angers us is, why is this so slow? And this is about people, individuals, not about some SLA green light on somebody's knock that says, on average, we're fine. Because if I'm the guy who in the 99th percentile is slow, to heck with your averages, right? I'm going to go someplace else. So I want to track individual people and understand what those unique individuals are doing in my environment. What are the transactions that they're hitting? And what are the dependencies that those are hitting downstream? So that means that I know that Angelo is doing a login. And those nodes that I've represented here could be network paths, they could be VMs, JVMs, CLRs, instances of applications, processes, or actual pieces of code under the covers. And we provide visibility into all that, as you're going to see. But the idea is to say, I'm going to start with the user. What is the user doing? Follow them through my ever-changing dynamic environment, and then use this as the basis for my analysis and monitoring to say, what is the profile of logins for the user community at a particular time based on the people who are hitting it? Maybe people behave a little bit differently before shopping season than before tax season, whatever it happens to be, okay? And then use this to create an aggregate view of my world. And this isn't a network topology diagram of this server talks to that server. This is in the context of particular end-user business transactions. And this is important because at the end of the day, everything that we're building with putting things in the cloud or still connecting the dots is to service these people and ensure that they are all happy with us. One of our customers, big customers, is a credit card company, and one of the major ones you have in your pocket. And all across their data center, they have signs that says, every transaction matters. Meaning every time you swipe, you get a response back in so many microseconds. And they don't want it to be on average people are okay, because they don't, if that's slow, they hold up checkout lines. They hold up people checking out on Black Friday. So it's got to be every single thing and not on average it's okay. And that's what we do. So you've got these different perspectives, and they're valid, but do we attack them as different separate views? That I have one tool for network, and one tool for app, and one tool for my end users. So if we think of this abstraction, here's a room, and on one wall there's a circle. No one's going to debate that. That's a circle. And on the other wall there's a rectangle. Again, that's a fact. But these are actually projections of some common entity. So what we really are dealing with here is a cylinder. But depending on how I looked at it, I have these views that are true, but the cylinder is the truth. That is the reality of what's going on. So if I have myopic views and sort of only looking one way or another, I'm going to have potentially different perspective. And visibility isn't just about knowing that something's wrong. My father always said, nobody likes a complainer. If you're going to complain about something, you need to offer a suggestion on how to fix it. So visibility has to be about providing actionable detail to the people who can resolve the issues, whether by provisioning more bandwidth, changing how we connect from our data centers into the cloud, whatever it happens to be, okay? That's what Steel Central Visibility is about that single source of truth, taking data from a bunch of different places and giving you that unique view of your world that helps you know if your customers are happy, and if not, precisely why, so you can take action and resolve those problems. So let's talk about this in practice now. You need to have telemetry from a lot of different places if you're talking about this global world. We need to know how the end users are doing, And that comes from their browsers, from their mobile devices, from the apps that they're running, and that's something that we provide clear visibility into. You need to look at the things that they're touching, the servers, the application code, the SQL statements, the methods. This is all cross a discipline, obviously. Not any one of us is going to know how to do all of this. We need to look at the network links that they're going over, the paths that they're taking. So we're going to need data from packets, from flows, from call stacks, from operating system metrics, synthetic testing, and so on. But the problem is that this is data that's some of this data is going to be very comfortable in the hands of some of us, but not others, right? So the network folks in the room are going to love their packets and flows, but not know what the heck to do with a call stack. And the developers are going to be the reverse. So Portal is our great normalizer for all this data that we're collecting from different places. And Portal says, now that we've got the data, I don't care what it looked like before, it's all just performance data. We have different ways that you can apply visualizations to this in organizations, and now create the views that are pertinent to you and your role and your workflows. So if there's, whatever there happens to be, 100 people in this room right now, there's probably 150 different ways you want to look at things. So we're giving you that way to have it your way and say, I have a particular role, I want to look at data a certain way. I'm an application owner, I don't want to get into the bits and bytes. Give me a roll-up that says there's something wrong with one of my apps, but have it be based on the low-level forensic detail that if that's red, your tools are going to tell you why and let you solve them. So they're not disparate tools that says, yeah, we have an alert, but everything else says it's okay. Or worse, something's wrong, but no one notices. No, it's all one set of data. It's just abstracted in different ways. So it could be as simple as that, or it could be as extensive as all these other views. And this isn't hard. Like these views I'm showing, the variety, it's all out of the box. It's wizards. You can go shopping and say, I want this panel from this dashboard and this panel from that. I'm going to make my own new one. This is not programming or consulting or anything like that, but allows you to create all these flexible views into your world and say, I'm a networking person, that's all I want to see. I'm an app person, that's all I want to see. I'm an architect, I need a view of the whole battlefield. I can do that. So the data is important that it's not segmented in how you're absorbing it, that when you have a view like this, it's maybe so subtle to realize that where does this all come from? This may look, okay, very simple, great, no big achievement. But to think about the fact that we've got data coming from client devices, from mobile devices of individual users around the world, and we're tracking those individual people. We're looking at the servers that they touched and the .NET code that's running in Azure that's been deployed, from Visual Studio. We're seeing those exact methods your developers wrote. We're looking at the network delays in between those links, knowing that if a delay occurs, you know what? The Azure servers are running super fast, but getting to my data center, oh, there's where my problem is. I have information about the VMs, the OS, and then, of course, my business level metrics that are telling me, am I meeting my SLAs, my commitments, and so on. So it's a beautiful interleaving of all of this different type of data, and then providing workflows so that people who are detecting issues at level 1 can take different paths, the Bugs Bunny left turn or right turn at Albuquerque type of thing, to say, I see a certain type of issue, I'm going to go one way versus another. And the workflows are super important. The customers that we work with, they want to be able to have very flexible ways of interacting with this data. So I kind of align this with, if we have video gamers in the audience, the top flow is like your open world type of game, where do what you want to, go what you want, you have all the power, you're the god, and you can eventually drill down into this very low-level forensic detail, and that's cool. And the bottom level is more like your first-person on-rail shooter. You feel like you've got flexibility, but in reality, we're taking you down a guided path. So we can give controlled access to the people who you don't want to overwhelm or just want to keep them sort of corralled to a degree, or you can say, you know what, I can go wherever I want to. And this is how our customers are using it, as simple or as extensive as it needs to be. This is Maersk International Shipping. Their data center is just blanketed with various Steel Central views. They have the overarching portals on the main screens. They have both technical views and business views, which the folks in the suits are looking at. And then that's your level 1, level 2, level 3 support. This is how they keep all of their international shipping working so smoothly. And we have lots of ways of deploying this. So there's different parts of the visibility. If any of this sounds interesting, come to our booth. Booth number? What's our booth number? 709. Big Riverbed. You can't miss it when you walk in. So if any of that sounds interesting, we can give you specific details on. I want to hear about the networking side, the end user experience side, whatever. But I'll just talk about one of our pieces. This is the application side. But this agent that does the code and SQL and server monitoring can deploy to Azure from Visual Studio as part of your application. So you have your existing application. You can go and get a NuGet package, which is our agent. That agent gets then absorbed right into your application deployment. So as you push the app up into Azure as a website or service, the agent goes along with it. It starts pushing its config to the main analysis server, which we have a cloud version, or you can deploy it, a SaaS version, or you can deploy it in Azure. It's also in the marketplace. And within moments, you're actually seeing this low-level detail that's telling you precisely why things are slow. So this is very fully integrated into the Azure ecosystem. So lastly, to tie all this together, right, we just wanted to really emphasize that visibility is key because you've got to address the happiness of the individual consumers of your data. So Steel Central is about this end-to-end visibility. It's about having that eye of Sauron to a degree and knowing all what's happening in your environment. And from the perspective of visibility, the rest of our portfolio, right, is about answering when we see that everything's okay or something needs to be fixed, who do I get involved? Steel Central tells us that. The rest of the portfolio helps us resolve certain issues on the fly when possible. Now, this is a chicken and egg type of way of using this. Visibility indicates issues that the rest of the portfolio can control and resolve, or you can start with the right and then have visibility to validate the changes you've made, right? So it works both ways. But the idea here is to say, if we determine that we've got a promotion going on right now and our service levels are starting to degrade because the key applications are not getting the slice of our pipes that they need to, Steel Connect can make a QoS policy change in the blink of an eye and all of a sudden change what goes where. And again, with the flexibility and agility that Azure's given us with spinning up and spinning down VMs, I can now do that willy-nilly, changing my network policies. And imagine trying to do that, going to your network admins now and say, hey, can you log into a couple hundred or a couple thousand routers and change QoS policies? It'll never happen. So that's what our platform is about tying together visibility and control capabilities so that you are now the general of the battlefield and you're controlling all of these and making sure that your system runs well. So with that, I'm going to turn it back over to Angelo, and let's see how beautiful the world is.
Great. So they'll turn my mic on in just a second. So thanks, John. So what we wanted to talk about is this is how you can realize the dream. Like Steel Connect allows you to take back control of that network and give you full control and visibility over what you're trying to do as you start to get away from individual link management and you just want your company to run better. Now, the one thing that we didn't show today that we're really happy to announce just recently is also we've integrated Zscaler, just like Azure has offered you Zscaler. We offer it as well from within the product. So with all that traffic steering stuff I was doing, if you'd prefer to not handle web yourself when you're a Zscaler customer, you can make a Zscaler WAN in 2 clicks and say, I want all web-based traffic at each branch to pick the best Zscaler entry point and go out from there. So if you'd like to see that, if you have more questions about that, come see us on the show floor. We're hard to miss. We can show you through, and we can probably answer some questions that you have on just what you've seen today. So if you leave here with one understanding, we just want to let you know that as you're building things into the cloud, you can either start climbing up these beanstalks and hitting thorns and falling and breaking your leg, or you could just bring the cloud closer. It's a lot easier if the fog just kind of descends and your journey becomes a lot shorter. So with that being said, I am fully aware that you had lots of vendors that would love to have had you in their session today. Thank you very much for your time. I'm going to draw something now out of a bowl of things, which marketing is probably going to run up here really frantically because I don't have the bowl. And we're going to see who won one of our brand new, really shiny and super cool Xeris access points, which are all cloud managed and no strings attached. I promise we won't call you and incessantly spam you. Yep, I got it. So I'm going to just randomly go like this. So check your ticket. And if you happen to have the number that it ends in 4008, just raise your hand. Because there you go, right here, sir. You are the winner of a very cool Xeris access point, which you can use and you can annoy your neighbors with because all the pigeons will fall out of the sky when you turn this thing on.
This is enterprise class. When I got one of these, all my Wi-Fi problems went away. It's amazing.
Yeah, you betcha.
Yeah.
So if you do have any questions, we'll hang out for a few more minutes at the front. You can come up and, by all means, just assault us with your unknowns. Otherwise, come see us at the booth. And don't forget, if you haven't got one of our shirts with one of our cool slogans, I hate carrying them home, so please feel free to grab one, give one to someone you like, someone you don't like, and make them wear it at the office. It's totally up to you. Thanks very much. Have a good day.